Assalamualaikum warahmatullahi wabarakatuh and good day. Today I would like to explain and discuss our final subtopic, equation of motion, general plane motions, under the big topic force and acceleration. Basically, we have covered two important subtopic before, translation and rotation about fixed axis. Basically, for general plane motion, it is a combination of these two motion, translation and rotation about a fixed axis. Alright. So if you look on these figures, figures A and B, uh, figure A is the figure given to describe the motions, forces, and everything. Uh, uh, and figure B is first one is the free body diagram, and the second one is kinetic diagram. All right. The basically for general plane motion, as I mentioned just now, general plane motion is the combination of translation and rotation. So it's combination of these two. Okay. Basically for general plane motion, the simplest one, the simplest example, or the basic phenomenon, basic phenomenon for general plane motion is a disc or wheels roll on the floor. That's the basic example of general plane motion. All right. For the example, for the example, if I have a wheel here, uh, throw from left to right. All right. And the center of gravity is very important to determine where is the G. Let's say this is the G. eh? When it rolls to the right, what happens is G is moving from one point to another point. For example, up to this point. So this is the position of your G, new G, the position. Eh? And while it moves from this point, point 1 to point 2, the wheel or this is also rotate. Okay, it's rotate. So this is what we call it general plane motion. Okay, if you go to a clear example of wheels rolling on the floor, so it's not as we did before in translation and rotation about fixed axis. You have to draw two things. First is free body diagram. So here you have to determine what's the force X on the rigid body, force, and then forces and basically external moment or couple moments. So you have to determine this one. And for kinetic diagram, is all about uh, the alpha and a accelerations. So it shows alpha and acceleration. Okay. For the example in figure A, we have this kind of motions. You have P here. P is uh, P is a force acted at point G, the center of gravity. And then it's rolled to the left, sorry, to the right for the example. And of course, for this rigid body, you have weight, you have normal force as usual, and you have what we call it friction force. Friction force to the left to prevent it from moving to the right. All right. So basically, we have, as usual, we have three important equation: summation of f in x, summation of f in y, and summation of moment. Where summation of moment, for the example, at g, or summation of moment at sorry at this point for the example. So basically we need these three equation. as usual. And then that, but don't forget you have to what we call it, draw the global coordinate system lah. Basically, positive y to the this is positive y uh, to the top. You have positive f to the positive x to the right. And then what you have seen here in figure B is only free body diagram. But if you can draw another one, which is kinetic diagram, what we can say is you have this one. You have A and you have alpha. Or you can write directly I alpha, or here MA. MA. Doesn't matter. As long as you shows A, direction of A and direction of alpha. And then that's the need of this one lah. But for the case of rolling, I want to talk about a wheel rolling on the floor. You can have two cases. You can have two cases. As I can say here, I split into two. First case is the wheel here roll without slipping. Okay. And number two, it roll slipping, or it's slipping, or it's slipping. Okay. For case of a roll without slipping, what you have to know is when it roll without slipping, uh, as we discussed in kinematics of a rigid body before, if it roll without slipping, you can say that first this is the point of IC. Okay, you can say that when it roll without slipping, uh, this IC is this velocity at this IC is 0. I put here V IC there is 0. Okay, that's for roll without slipping. Okay, as we discussed just now, we have three important equation here. It's needed here. You can have summation of f in x, for the example, is max, or you can put g there. Okay, agx is not 0, since g moving to the right. Summation of f in y m a g. Okay, in this case, for the example, in this case, it roll to the right on the flat surface, on the flat floor. Of course, AGY is 0, because this wheel doesn't move right and down. But if you have this kind of case, for example, it's roll in the inclined plane. For the example, you can have X motion, Y, for the example. Okay, and then you have another one, summation of moment, for the example. If you choose G, you can say that IG alpha. But if you choose a point to replace another point to replace T, you can, for the example, IC, then you can have IC alpha, IIC alpha. Okay, basically you need one more. You basically, so I basically you need one more equation. Since this is a case of roll without slipping, the equation we learned before, when we have IC here, you can determine at any point based on this rigid body, you can find its acceleration. Correct? For the example, point G, so AG there is basically RG to IC times alpha. Basically to solve these three equation, either one, you need one more additional equation to solve it. AG is RGIC alpha, means the AR alpha. Okay, that's the case of roll without slipping. If you use a roll with slipping, so this point is not 0, this is not IC, since it's roll without slipping, like you pull it, and then it is the rotational is not simultaneously rotate as you pull the as it roll to the right, so there's no point of IC on this rigid body, and you still remain use it, summation of x f so fx is equal to m x, summation of f y is m a g y, and then summation of moment g I j alpha, or this one, or you can, if you want to choose other point for the example, m for the example this point, or another point for the example only. It's easy to use point G. Let's say this is point A. You can use point A as well. It's up to you. So here it can be I, A, alpha. Okay. So we cannot use this one anymore. This case is for this AG is R alpha is the case for row without slipping. If you want to use, of course, you need one more equation to solve it, but not this one. Not this one. So what the additional equation you needed is f, as you used to work with before. Summation of f, is sorry, f, and the friction force is equal to mu k. This is the case of a roll without roll with slipping. All right. Basically, in the problems, in the problems or equation in the question given, sometimes they mention either the case is without sleeping or with sleeping. So if it's given to you without sleeping, it's easy. You can use the option one, by having this additional equation. And then if it mentioned that it's a roll without sleeping, you can use this one directly. The option number two directly. But most of the questions, sometimes it doesn't give you the situation, either it's roll without sleeping or roll with sleeping. Sometimes you have to determine yourself from the figure. Sometimes from the figure you can identify either it's roll without sleeping or roll with sleeping. Sometimes, but if you are not sure whether the case is roll without sleeping or roll with sleeping, you have to choose either one first, and then you have to check. How to check it? Okay, for the example, I prefer, if the situation or condition is not given, you choose the option one first. We assume that it roll without sleeping. That's the first one. You choose a roll without sleeping solution and solve it. And then what you have to do, what you have to do, let's say for this case, for this problem, once you solve it, you get what? You can get what is a, for the example, P is given 10 Newton. For the example, you find you got you got alpha, you solve, you got F, you got N for the example. You have to check. If you use the option number one, I prefer to use this one first, a roll without slipping. You have to check the friction force there. Put the F here, it's better, friction force. You have to check either FA, you have to check FF. You have to compare the friction force with the mu s, the coefficient of static friction times normal force. If it FF is less than mu Sn, so your assumption is right. Assumption is right where it roll without slipping. Right? Of course, you choose the first option. You solve it using the first option first, and then you have to check either FF is less than mu S time N. And then you found that if if you found if equal, ff is less or equal to mu s times n, yes, your assumption for its row without slipping is right. But if you found that ff is greater than mu Sn, so your assumption is wrong. When your assumption is wrong means that it roll with sleeping. What happened? You have done your solution using the first one. Okay, first one. So what you have to do is you found that the condition is wrong. For the example, ff is you found that ff is greater than mu s times n. So you have to rework. You have to rework your solution by choosing the second option. You have to use ff is equal to, we have to use, remember, to check the condition either is row without sleeping or with sleeping, you have to mu s times n. But once you check that it is a row with sleeping, you have to use this one, ff friction force is equal to mu, okay, kinetic friction times n. Okay, that's that's the what should you do you when you face this kind of problem. All right, so I think that's the basic fundamental of general plane motion. When I think for the next video I will discuss about 2 or 3 examples so that you can understand more about this subtopic, general plane motion. All right, thank you very much. So see you in the next video. Assalamualaikum warahmatullahi wabarakatuh.